today's problem from number theory and using Fermat's theorem. Okay, and the problem is if GCD of a, 30 this is equal to 1, so that 60 divides a to the power 4 plus 59. Okay, so we have to prove a to the power 4 plus 59 congruents to 0, this is mod 60. We have to prove this. That is, we have to prove this a to the power 4 congruents to minus 59 mod 60. Okay, and this is given by a to the power 4 congruents to 60 minus 59 mod 60. Okay, that is, we have to prove that a to the power 4 congruents to 1 mod 60. We have to prove this result to prove the required result. Okay, and we use the relation. The first one is the Fermat's theorem. The statement is p is a prime number and a be a number which is not divisible by p. Then a to the power p minus 1 congruents to 1 mod p. And the general form we get multiplying both sides by a. Okay, and the second result is 3 properties of congruence we use here. Here first condition is given that GCD of a, 30 this is equal to 1 and 30 can be written as 2 into 5 into 3. Okay, 2 into 5 into 3. So we can write 3 result that GCD of 2, a this is equal to 1, GCD of 5, a this is equal to 1, and GCD of 3, a this is also equal to 1. Now if we take p this is equal to 5 and use Fermat's theorem, we can write this is a to the power 5 minus 1 congruents to 1 mod 5, that is a to the power 4 congruents to 1 mod 5. Okay, now for p this is equal to 3, we can write this result as a to the power 3 minus 1 congruents to 1 mod 3, and this can be written as a square congruents to 1 mod 3, and this gives a to the power 4 congruents to 1 mod 3. Okay, we use this result and this result to prove our final answer. Now for the case p this is equal to 2, here 2 is remain. In this case we can write using Fermat's theorem, this is a to the power 2 minus 1 congruents to 1 mod 2, and from which we get a congruents to 1 mod 2. That is, we can write this result as a square congruents to 1 mod 2. We use here, here and here use this theorem or this property of congruence. Okay, now from this relation, this is also an important relation to use the final result. From this relation we can write a square congruents to 1 minus 2, this is mod 2. Okay, so a square congruents to minus 1, this is mod 2. This relation we can write 2 divide a square minus 1, and from this relation we can write 2 also divide a square plus 1, because this is a square congruents to 1 and this is a square congruents to minus 1. Okay, so combining these two results we may write that 4 congruents to a square minus 1 into a square plus 1, right? So we get 4, this is divide a to the power 4 minus 1. So we write the result from these two relations as a to the power 4 congruents to 1, this is mod 4. How we find here mod 4? Because when we divide the given number 60 into the prime vector, we get 2 square into 5 into 3. Okay, so here we get a to the power 4 congruents to 1 mod 5. Here we get a to the power 4 congruous to 1 mod 3, and here we get a to the power 4 congruous to 1 mod 4, and we can write this is mod 4 or mod 2 square. Okay. Now since GCD of 2 square 3 5, this is 1. Okay. So we use the second property of congruence. We may write that a to the power 4 congruous to 1, this is mod 2 square into 3 into 5. That is, we get the result a to the power 4 congruous to 1, this is mod 60. Okay. Now a to the power 4 congruous to 1 mod 60, this means a to the power 4 congruous to 1 minus 60 mod 60, and this gives a to the power 4 congruous to minus 59 mod 60, that is a to the power 4 plus 59 congruous to 0 mod 60. Okay, and this is our required result. We prove here 60 divide a to the power 4 plus 59. Okay, very interesting and important problem of number theory, and we solve it using Fermat's theorem. Okay, thank you for watching.